Good evening, everyone. This is Professor Lewis, and today we will focus on Module 4, Functions. So for today's live demo, I will cover Module 4, Functions, and it shows how functions will make Python program clearer, more reusable, and easier to test. We'll move from defining and calling void functions and laying out a simple menu we'll be using parameters, local variables, globals and constants, and value returning functions, along with the random function, and the math module. And then we'll also use various menus to help organize those functions better. And you'll see as I walk through this demonstration what I'm actually referring to there. And then we'll take a quick look at the pass keyword in order to create various stubs. Okay, we'll close by wrapping a call to the Azure Translator, right, in a value returning helper function. All right, and then running the full menu-driven application end to end. All right, so this will be a menu-driven application that demonstrates the various functionalities that functions provide for us. Okay, all right, so let's get started. So as you can see here, I currently have Module 4, our package Module 4 set up. Okay, so functions. So basically, what are functions? All right, and as your textbook states, functions are reusable blocks of code, right? That takes inputs, which are known as parameters that we define in our functions. They perform a task, right? And they can optionally return values, making our programs more clear and drier and easier to test. And when I say dry simply means don't repeat yourself. So functions allow us to place tasks in one specific location, that function, and we simply reuse it, right? There's no need to repeat that same code over and over again in our program. So in this demonstration, I'll create two Python files. The first will be a function demo application that will be the module that drives the program. And then I'll also create a module called the Python functions, right? That's where all of our functions will reside. So we'll take a look at how to import, right, functions into other modules as well. Okay, so let's go ahead and let's do that first. Okay, so of course I select my package, right click, select new, and I scroll down to Python file. All right, so the first file that I'll create is called functions underscore demo underscore app. Okay, so this will be our driver, and I'm going to go ahead and add this to our GitHub. Okay, so we have our application file that will be the driver. All right, secondly, I'll create a Python file that will contain all of our functions, right? Our void functions, our return value functions, and those functions that will use the math and random modules. All right, so let's create that. So we'll call this Python functions. Okay. All right, so we're going to be working with two different files. All right, so the very first file, right, this application, which would be our driver, this particular file will contain our main. This will be our main driver file. All right, so in Python, a file can serve two different roles. All right, it can either be a library or a module that you import from other files, right? And it can also act as a standalone script that you can run directly. All right, so the application file here will be our standalone script that we will run directly to execute the entire program. Okay, so, and I'll type out the code. I'll create the module, the code in this module very shortly. So what we're doing here, we're going to add this safeguard, right, that lets the same file either be imported into another module with absolutely no side effects, or it can be executed directly. Okay. All right, so let's go ahead and let's create our very first function. All right, and this will be our driver. I'll close this module out there. All right, so the very first function that we'll create will be our main function. Okay, and remember there are two important things when you're creating a function. All right, the function header, which is basically our signature, which entails the def keyword along with the name. We'll just call it main. And then it will always contain open and close parentheses, all right? But you can have parameters that are defined here as well, right? For this instance, we will not define parameters. Also, another important item to know when you're working with functions, the indentation of the body, right? You must indent at least 4 spaces, right? This is where the code of the function, right, is executed and it is ran. All right, so here, I'll just simply, after my indentation, I'll simply type in welcome to the functions demo. All right. Okay, so what I was referring to in reference to there are 2 roles, right? So we can just leave this file the way that it is, and it will just run as we can just import it as a module or a library. However, Python offers this safeguard, right, where we can have different scripts that we may want to run individually, right? So we always want to add, in this instance, we'll add this if statement, right? If underscore name underscore equals main, right? Then, and we run this file directly, right? Then the Python interpreter knows that we want to execute this particular script, right? We want to run it as our main executable file, if you will. All right, so I'll type if double underscore name, and name, this is a special variable that Python has. All right, so if main underscore main, okay, and here I will invoke our main function, right? And it doesn't have to be called main. We can give this any name that we choose, right? This is Python specific on line number 9. All right, this simply tells Python, this is a safeguard, right, that gives us the option to run this file independently, right, as a standalone script, right? And we can also import it, right, as a library into another file, right? And one of the reasons for this is because in Python, there are times when you can have multiple scripts, right, that need to be ran independently. All right, if you want to do some type of maintenance, well, maybe just one particular module does maintenance or does a certain check on your file system. All right, so you just want that particular script to run. All right, so having line number 9 included in that script allows it to execute independently. All right. Okay, so with that said, all right, so we've created our application, our driver, our main driving application that will drive the entire program. All right, so next, all right, so the next step is we want to define and create a void function. All right, so I'm going to define a void function, right, and then call that void function from our main function. Remember, this functions underscore demo underscore app is our driver. This is what is driving the entire application, right? In our second Python underscore functions file, this is where all of our functions will be. Okay, so what does that mean? That means that we're going to be importing, all right, these various functions into this application file here. Okay, so at any rate, so let's have a little bit of fun. All right, so a void function basically is a function that performs a particular action, but it returns nothing explicitly. All right, so let's add a greeter function, something really simple, and we'll call it from our main function. So let me just kind of separate these two out here so we can see clearly. There we are. I'll just scoot that over there so we can have larger landscape there. All right, so if I want to create my greeter function, right, again, I'll simply use my def or definition keyword. I'll call this greet user. Okay, my parameters list is empty. All right, and here I just simply want to print something out. If I do something like hello, exclamation mark, welcome to the functions demonstration. Okay. There we are. Bingo. All right, so here we have a simple function, void function, that returns nothing. When we return something from a function, we're going to use the return keyword. All right. So if I want to test this out in my driver file or my application file here, I can do that. All right. And how do I do that? I will invoke indent 4 spaces, right? And I'll invoke this function, greet users, from my main function here. Okay, so I can just simply type in greet. If you notice, the interpreter automatically recognizes that greet user function in the other file. All right, so if you notice here, we're doing a couple of things on line number 1. All right, so I've invoked here my greet user function, right? Or I'm calling the void function. All right, that's another word, invoke or calling. They're synonymous. All right, but more importantly here on line number 1, this is important how we're able to use functions inside of other modules. So what this is stating here, what this says on line number 1, it's stating from my source folder, which contains my module, my package, module 4, all right, and my module Python underscore functions file. All right, so we're stating from this file or from this path, all right, there must be a function, or it could be a class, but in this instance, it's a function. All right, so we're saying import it into my application file so that I can use it, so that I can invoke it or call it here like I am on line number 6. Okay, and since we have added our if name equals main statement, right, I can run or execute the entire program from my applications file. Okay, so when I click on my little green button arrow there at the top, and it takes a second, I just think I have too many windows open. Okay, so here we get the full each line of code. Line number 5, welcome to the functions demo. I invoked greet users. Well, what are we displaying? What is the code inside of that function? Hello, welcome to the functions demonstration. Okay, So here I am invoking, I've imported this function into a different module, my applications module, and I am invoking it from a different function, the main function. Okay. All right. So this is a simple void function. It doesn't return anything there. Okay. All right, moving on. So as I stated, we're going to create, this will be a program that will display, where we'll build multiple types of functions. All right, so we're going to create first, right, this menu that displays a list of all of the functions that we want to execute. And what this does, it actually helps us organize our program more efficiently. All right, so we're going to have multiple functions that we're going to execute from this main function, like we did here, greet user. Okay, but before we do that, we want to be able to see the different types of functions. All right, so I'll create this simple display menu that displays all of the functions that we're going to create. All right, so for time, and I'll add it here to my, let's see, yeah. I'll add it here to my application. I debated on putting it inside of the Python functions module, but I think it's better here in the application module. Okay, so what I'll simply do for time, because it is not linked super long, but it's long enough. I'll just simply copy and paste it, what I've already created, and add it there. Okay, and give me a moment, let's see why. Missing my quotation marks. Actually, I have all this already prepared. So I'm adding quotation marks. What it's saying is that this is a print statement, and I want all of these items, 1, 2, and 3, right, to display as a string. All right, that's all this is saying here. And I actually thought that I had my quotation marks, but evidently I did not. No problem. All right, so let's do the last two here. Let's close these on out. I like this one here. This one had the last quotation mark in it. Perfectly fine. All right, so now if I were to add, so this is my show menu function. All right, and this function will simply display function demo menu, my greet function, which is a void function. By area, we're going to determine the area of a circle function. We're going to implement a roll dice function. We're going to also translate text using the Azure Translator, which is really cool. And then we'll take a look at Lambda and mapping, all right, functions. And then finally, we'll take a look at how to use stubs, create stubs by using the pass keyword. Okay, so this particular menu, right, will just simply display these options for you. All right, that's all its purpose is. It's just to print out the display. And as we scroll, as we build this main function here, you'll see very shortly, all right, it will allow us to invoke, all right, the function. So let's build out the very first one here. Okay, so let's say, and then the rest I'll just do copy and paste as well. All right, for time. It too is fairly long. Okay, so let's just grab it. Okay, I'm going to remove this greet user, and you'll see why very shortly. All right. Scroll this down so we can all see what's happening here. Okay, scroll down here. Just a moment. Why are we not allowing me to scroll up and down on that? Okay. All right, I'll come back to that and figure that one out. All right, so here, if you notice, all right, so in our main function, right, it will display welcome to the functions demo. However, right, in this particular function, right, our main function, we're going to use if, elif, and else statements, right, to select and call or invoke the functions that we're going to create. And as you could see, under the red little squiggly lines, right, are giving us an error because we have not created those functions yet. All right, those functions will appear in our Python functions module. If you notice, greet user, right, is perfectly fine because it has been defined in that module. Okay, so this menu uses a while loop that, as you can see here, it's using a while loop that is set to true, and it will continue to display until the user enters 0 to exit. All right, so if you scroll all the way down there, right, so when the user selects 0, it will break. All right, so the break is executed and the program ends. All right. Okay. If they choose something, an invalid number, right, like let's say 7, all right, the else block will execute and say, please choose 0 through 6. Okay. All right, so this is so in order for this to work, right, so the first thing that we want to do as we iterate through our while loop, all right, we're going to invoke that show menu that I just created here. All right, so what it will do, it will show, all right, our options. Like any application, we want to see the choices that we can choose. All right, so it will display our options, and then we'll simply make the choice. All right, so here, after it invokes the show menu, all right, we're prompting the user to choose an option. All right, and we're stripping out any spaces that may be, if they do space 1 or space 2, it will strip that. All right, it shows the available actions. All right, so here we're going to store that value. Let's say for greet users, right? It'll store the value number 1 inside of there. All right, so if the choice is equal to 1, it will invoke greet user. All right, and our greet user function will display. Okay, so for now, what I will do so that we will not get any errors, all right, I will comment out until we build out these functions. All right, comment those out. So the only function that we have, the only option that we have is option number 1 at this current time, since we only have one function built. There we go. So I'm say, what the heck? All right. Okay, so when I run this application now, all right, so if I run it, okay, so now we have functions demo menu. okay, to greet, I keep saying create, to greet, to invoke the greet user, right? Our void function, we press number 1. The area of a circle, number 2, right? So when we press number 1, right, that choose option that we've defined on line 18 here, right, it will automatically assign the value 1, and then it will test the condition, all right, for all of our options. But for now, we only have number 1 available. All right, so I will choose number 1. Okay. And it will display, hello, welcome to the functions demonstration, okay, which is what we have defined inside of our greet user function. Okay. And if you notice here, it prompts me to scroll down here, choose an option, right? So what does that mean? That means that our while loop is still true. It's still set to true, which is what you want, right? Because we only want this to become false, right, when we choose 0, and it will break out. It doesn't necessarily set it to false, it just breaks. It exits out of the while loop. We could have set it to false, but this is a more efficient, easier way to do that. Okay, so when I type in 0, right, it says goodbye, just as we have here on line number 33. Okay. All right, so moving forward, let's take a look at creating a value returned function, right, that calculates the area of a circle and then returns that area, right, using local variables, passing arguments into our functions, and then using a global constant pi. Okay, so what does that mean? That means that since we're creating a function, all right, we're going to create that function in our Python function module. All right, so let's do that. All right, so the first thing that I'll do is to create this constant, right? Now I'll create this constant pi. Of course, everyone should know that pi is equal to 3.14 and multiple numbers beyond that, but 3.14 is good enough. All right, we can either type in equals 3.14 manually, right? Or we can use the math module and one of its variables, pi, that already defines it for us. All right, so these are called built-in modules or built-in functions, functions that are part of most programming languages. All right, Java definitely includes a math class, is what we call them in Java, right, that defines pi as well. So instead of using a hard-coded value, 3.14, we can use the math module. And if you notice, right, this module is just like the modules that we're creating here, right? Math is. And it has various functions or variables as well that are listed inside of that module, right? And we're able to simply use them. It's why they're called built-in modules or pre-built modules, right? And as you can see, we have a plethora, right, of functions that we can use or different variables. So there's our pi, right? So we want to use pi. So what does that do? It automatically assigns 3.14 to our constant, all right? And this here would be considered a global constant. Why? Because it is listed, I'll put it at the very top. Most global constants should be at the top of your program, all right, the very top, so that other developers, when they see this, they're able to recognize, oh, we're using a constant pi. Okay. So what that means as well, if it's global, that means that any function inside of this module can use it. All right. It's kind of frowned upon to use global constants. Constants are okay, right? Because once the application is running, that constant cannot be changed, right? But you can also sometimes, as a new learner, maybe have an idea to create global variables. All right, and global variables is something that is kind of shunned upon, right? Because those variables, and what do I mean by that? I can do something like name equals my name, right? Something like that. This is a global variable, right? Outside of any function. All right, so that means that every function has access to this and they can change the value at any time, right? Unlike a constant, once the application is running, that constant's value remains the same, right? So it's kind of shunned upon to use variables as global values, but more preferably to use them inside of your function where they're being used. Okay. All right, so we've created a constant called pi, and we want to create a function that will compute the circle, the area of a circle. All right, so let's do that. Let's keep this nice and neat here. All right, so I'll use my def. I'll call this compute circle area. And this time I am defining a parameter, okay, inside of my parameters list, inside of my definition, all right, signature for my function, okay? And this particular parameter, radius, is local to this function, okay? Meaning that Greek users could not use this radius here. All right, so when we define parameters inside of functions, it's local to the actual function, okay? Or the variable will live only inside of this function, if you will. Okay, that's another way of saying it. All right, so let's create area. Okay, and we'll use our pi that we defined and declared. Okay, and we'll use the radius that the user will pass in. We'll use double asterisks to indicate exponentiation, right? So radius to the power of 2. So that's simply what? Radius times itself. Radius times radius. Okay, that's what this is saying here, right? Radius to the power of 2. But radius to the power of 3 would be radius times radius times radius. All right, I think you get the point. All right, so double asterisk is exponentiation. All right, so we're going to simply calculate the area of a circle based on the radius. All right, so where are we getting that radius from? That means that a user will have to enter the radius as an argument or pass in a radius as an argument. All right, whatever value is in that radius, it will be to the power, will be set or calculated to the power of 2. All right, so if I pass in 2 as my radius, I will have 2 times 2, which will give me, what, 4. Then multiply that by my pi, 3.14, and that will give me my area of the circle. Okay. So once all is said and done, we want to return our calculated area back to the caller. All right, meaning whatever function or whatever line of code called compute circle area, we want to return the results back to them to do whatever they choose, right? Or to do whatever it chooses. Okay. All right, so in this demonstration, what I've created are functions that are called, it's part of the flow layer, right? So most functions in most cases should only, just like in Java, they should only do one thing, right? You should not have a function that is prompting the user to enter values and then do calculations on those values and then return that, right? You can, there's not really a problem depending on the specifications and the company that you'll be working for or that you work for, right? But it's always good to put one type of task inside of a function instead of multiple tasks because it's easier to maintain and it's definitely easier to debug. So what I've created is this flow layer, right? And we'll call it the area flow, all right, function. Okay, and what this function will do, it will handle the user's input and output, right? And it will also validate. So it's actually kind of doing two things, right? And I just said don't do two things, but once you receive the information or the input from the user, you do want to validate it, right? And I could have created a different function to validate the input as well. But for simplicity at this juncture, we'll prompt the user for the actual radius, and then we'll validate, right, that radius to ensure that it is in fact a value, a numeric value, and not a text value. All right. So let's do that, and we'll continue to do that, all right, while it's true. Okay, so we're going to add it into a while loop. All right, so I'll start coding. All right, so here, while true, text equals input. So enter radius. Okay, so I'm going to implement the try exception or try except, right? So even though I think our chapters, a couple of chapters from now, we're going to cover that. I notice some of you all are already using it, which is great, right? So you want to always tell the interpreter to try doing this particular task first, right? So just in case something happens, we want to be able to catch it and gracefully shut it down or gracefully send a message to the user, right? Instead of just having the program crash because of incorrect data that the user typed in. All right, so we're going to create a try block, right? And we're going to say radius equals, we're going to convert that text into a float. Right? Another term for that is casting, right? We're casting the text that the user entered into a float. Why? Because we know this input function, right, accepts it as a string and it's stored as a string there. All right, so in order to do our comparison, right, we need to cast it as a float. All right, so we're going to use a simple if statement here. If the radius, right, is less than 0. All right, let's move this down some. If the radius is less than 0, okay, then print that the radius must be 0 or greater. Try again. All right, so that means that the radius cannot be a negative number, basically, right? -1, -2, and so forth. Okay. And then continue, right? And what does this continue do? It will loop back for another attempt, right? It will prompt the user again. Okay, you entered a negative number, enter the radius again. All right, it doesn't exit out of the loop. It'll just loop back and prompt the user for another attempt. All right. Or else, if the user enters a valid number, right, anything greater than 0 or greater, then it will exit out of the actual while loop because we have a valid input number. All right, so we'll exit out of our loop there. Okay, so next we need to handle our try just in case something goes awry. all right? We want to use this value error, all right? And this is raised when when this particular function gets an inappropriate value, right? So for example, they're trying to type in a non-numeric number or non-numeric value, such as characters, like, well, not characters, but letters, like the word ABC or something like that. That's clearly not we clearly cannot convert the ABC to a float, right? So we're catching that type of error here. And I notice that some of you all do use this, right? And some of you use the value error exception, right? And then some of you have not. So you may, if you're checking to ensure that the number entered is in fact, the value entered is in fact a number, I would highly recommend using the value error exception, right? And then we want to tell them something. We want to tell them to print, please enter a number, right? And we can give them an example, something like, let's do EG, I don't know, 7.5 or something like that, or even just plain old 7. If it's 7, it's going to convert it to 7.0, all right? And let's do it that way so it can really make sense. Okay. All right, so it hasn't, if it hits this exception, right, it will simply traverse back, it will pass control back to line 13 and reprompt the user to enter a radius again. All right, and that because we haven't broken out of the while loop. The only way that this while loop ends is through this break here. So we'll just continue to prompt and prompt and prompt until the user basically types in the correct value. All right. All right, and then finally, all right, once we break out, we want to do our calculation. So we'll create a variable called area. Okay, and this time we will invoke the compute circle function. Okay, and guess what we're passing into there? We're passing in our valid radius. Okay, that was entered and validated. Okay, so we're passing radius, which will be considered an argument. We're passing this argument radius into our compute circle area function. Okay. So the compute circle area function will receive whatever value as an argument. If you notice, when I highlight line number 8 radius, it highlights line number 9. So what does that mean? That means whatever value I'm passing in, it will be the same value that will be used in this math formula. All right, so if I type in 2, it's validated. All right, pass in 2 as the argument. It will be 2 to the power of 2, all right, which will give us 4 multiplied by pi, all right, and it will store that result in the area variable. And what does it do? This is a return function, so it will return that value back to the caller. And who's the caller? Line number 23. This is where we invoke that function. So it will return the results back and assign it into our area variable. Okay. All right, and the only thing we need to do is just simply display it. All right, so we'll just do a quick printf. And we'll do something like area equals, these are placeholders, area. And we'll give it 4 spaces to the decimal. Okay, using pi. Close parentheses. Okay, so why am I doing this using pi? All right. I'm implementing this here to show that we're able to use a global constant, right, in any function. All right, so remember, I defined that global function, our global variable here, our global constant, correction, here on line number 3. So if you notice, when I highlight pi on line number 3, on line number 24, pi lights up. All right, so what do you think we'll get? 3.14, or whatever value that math.pi has defined, which I think it is 3.14 without all the extra values to the right of the decimal. Okay, so in addition to that, it will display our calculated area. Why? Because it was returned back to us after we passed in our radius argument. It did its calculation here. It returned the area back to the caller and assigned it here inside of our area variable. If you notice, when I highlight area on line 23, area on line 24 also lights up. Okay. All right, so let's go back to our main function in our application file and look at what we have here. We have, for choice number 2, area flow function. All right, well, there's our area flow function that we defined. So now when I uncomment that, all right, well, we're still getting an error. I wonder why. Well, it goes back to our imports. We haven't imported that function into our application module. So in order to use it, we need to import it. So simply hover over that little error, red squiggly line, click on it, and now we have the area flow function inside of our application module. Okay, you notice the error has gone away. So when I run it, this time I can choose option number 2, area of a circle. I choose it. Okay, it's prompting me to type in my radius. All right, this is what we typed in on line number 14, type in the radius. So let's just use 2. Been working with that all throughout the demonstration. Let's use 2. And it did give us the full. This is how it defines it. Quite interesting. All right, so here it gave us our calculation, right? So it's a valid number, right? 2, it converted it to a float, right? And we did our calculation, and we passed the number 2, right, into as an argument into our compute circle area. It calculated it, right? It returned control back and assigned that result, okay, to area. And now the area equals, okay, 12.56664. All right, we wanted 4 spaces to the right of the decimal. That's what we got. All right, if I just want 2, I can do that as well. All right, so we'll run it very shortly. And then it's using pi, 3.14, and all of the digits to the right. All right, this is what math.pi defines the value of pi as, which it is, right? But it provided the full value, or close to the fullest value that it can display, okay? Instead of just the 3.14. Okay. All right, so some of you, I noticed you're not using your F string, so use your F string so that you can really customize what your outputs look like. All right, so here again, so initially was 4, so if I run this again, I'll pause, stop it, run it again. I should have did 0, but it's no big deal. Okay, let's run it again. Okay, I'll select option number 2, type in 2 as my radius. And this time, if you notice that 0.2f, all right, it only gave me now 2 spaces to the right of the decimal. Okay, so formatting allows you to do, F string allows you to do multiple types of really nice outputs to your code. All right, so next, let's take a look. And even though we have basically looked at some a value return function, all right, let's take a look at how we can create our own value returning functions, right? By using random numbers, right? So we're going to use the random.randInt function, right? That returns integers between the values that we're going to define. And the values that we'll define are values 1 through 6. Okay, so let's just take a look to see what that looks like. Okay, so I'll pause or stop our program. I guess I should exit out instead of getting that error every single time. That would help it out just a little bit. All right, so the next function that we'll create is a value return function that uses the random.randInt function. Okay. All right, so let's do that. All right, so, and I'll just kind of walk through it as I define it. So we'll start this out with our def, and we'll call this function roll_dice. And this particular function will not have parameters defined. It's just an empty parameters list. Okay. So I'll create my first die. Die 1 is what I'll call it. And we'll use the random dot rand int function. And we'll set our values 1 through 6. Okay, so if I was trying to use NumPy random, and that's not what I want. All right, I don't want the NumPy.random. I just want plain old random. All right, so I'm going to backspace that out and re-import random. Okay, so it gives me options, right? It's giving me an option, and if you notice here, which is really interesting, right? It shows you where you can actually implement what import to use, all right? So here it's showing the Python random import. That is the import that we want to use. The NumPy random we don't want. The random we don't want. All right, so we just simply import our Python. And how did I know that was the Python? It had the little symbol, the Python symbol. That was a huge help there, right? So the key thing, NumPy is normally used when you can use it for multiple things, but in statistics and when you're doing artificial intelligence, building out models and things like that, which is what we're not doing. All right, so here, right, I've simply imported the Python random function or module. Okay, and inside of that module, what do I have? I have the function randInt, right? Random integers. Right, so here we are going to exclusively, this particular function, right, will exclusively call or return exactly one of 6 integers. All right, so when I say exclusively, that means that it will include the number 1 and it will include the number 6 as well. All right, so that's for die number 1. So for die number 2, we'll do the same thing. Random dot randInt. Okay, 1 and 6. Okay. And if you notice here, it kind of provides you with some properties, right? Or attributes. A is 1, B is 6. A is 1, same thing, B is 6, which is nice, all right? That kind of helps you determine when you're writing larger code, right? Which one is your beginning and which one is your end for the most part. All right, so here we're creating our own return value function. So I want to return not just what the random int chose for me. I will return that. However, but before I return it, I want to add those two together, sum them together. All right, and that will give me a different value. All right. So this is what we call just a pure function. No, there are no prints inside of it. No, print this or print that. It's just a pure function, right? And what it does, it will get 2 random numbers, assign one to die 1, assign the next to die 2 variable, It will take those two values, sum them together, and return that value to the caller. Okay. All right, so hence, again, our return value function using the random.ranInt. Okay, and this is called the dot notation, right? I use this quite a bit, right? This dot, it's imperative to understand in programming, right? It allows you to use in this instance, the module name dot, right? Just like math, dot. And when we type in that dot, we get a plethora or a list of other options, right? Other functions or other properties that we're able to use that are inside of this random module. The same as we did with the math at the very top, right? We saw all of the dot, right? It affords us the opportunity to take a look inside of that module. What's there, right? Well, random is the same way, right? All right, so this is a pure function. No prints, no outputs, no nothing, right? All right, so next we want to create this roll dice flow. Roll dice flow, right? Again, this flow will handle the input output, right? And it will invoke, well, it's not necessarily, it's invoking the actual roll dice function, all right? But it is handling the output. So it's going to display what their results are, what the total is, right? After we sum those two together. All right, so I'll create a variable called total. And here I am going to invoke my roll dice function. So if you notice when I highlight roll dice, open and close parentheses allows the full invocation or call, right? On line number 27 is also highlighted, right? So that means it's referring to the same function, okay? So here I will just simply print out using my F string, you rolled a total of total, and we'll do exclamation mark, okay? All right, so the beauty about this is once I invoke this function, all right, it rolls the dice for die 1 and die 2. We get two values, it sums it, right? On line 30, after it sums those two values, it will return to the caller. And the caller is on line number 33. So whatever the results are from this sum, this addition here, right, it will assign it to our total variable. Okay, so remember, the assignment operator simply states whatever is on the right side of it, right, you're going to assign to whatever is on the left. Simple as that. Okay. All right, so now when I scroll down my list of choices, all right, we have roll underscore dice flow. Well, that's the name of our function here. So that is the function that I want to invoke. So I'll uncomment that out. And we have our error again, all right? Why? Because we need to import it. We need to tell the interpreter, look, we need to use that function. So import it into my module. So let's do that. Highlight it and then click on it, that little blue link. And now we have roll underscore dice underscore flow imported into our application module. All right, so when I run it, this time I will choose option number 3. Okay. Okay, so option number 3 shows that you rolled a total of 8. Right? But then you say, well, Professor Lewis, you said it can only go 1 through 6. Right, but remember, right, if die 1 was assigned 2, and let's say die 2 was assigned 6, all right, then the sum of that would be, of course, 8. All right. So this is how we were able to roll 8. So if we do it again, it's number 3. This time we rolled 6. Do it again, one more time, then we'll move on. All right, this time it rolled 10. Okay. All right. Okay. All righty. All right, so that's this is one way in which you're able to create your own return value functions. All right, just have pure functionality in your function, no print statements or anything like that. All right. And then here in this instance, I'm using a flow layer, right? Something that handles the invocation of that function and does the output of that function as well. The results that were returned from that function. Okay, all right, so let's take a look at lambdas and mapping. Lambdas and mapping. So map basically, so they're functions, the map function and a lambda function, all right? So the map function applies a specific function to each item in a sequence, right? A list. Right, and returns the transformed result. All right, a transformed result can simply mean just adding two values together or summing or accumulating values in one variable. So that's what we mean by transformation or the transform result. It's just a shorter way to implement this process by using map, right, and lambda. So lambda lets you create this little tiny anonymous function, invisible function that's inline, right? It's an inline function, and it's perfect for this quick one-off transformation, right? So what do I mean by all that? So let me just type in some stuff here, type in some code so that it can make a little bit of sense to you. All right, so let's say that we're going to create a function, right? And we're going to create a function and then add the map and lambda function inside of it. And you'll see what I'm referring to. All right, so this particular function will just have a list, and inside of my list, all right, will just be 4 numbers, all right? And I will traverse through my, my list and pass in each value into my lambda function to add that, prompt the user to enter a number, and that number that the user enters will be added to each value in the list. All right, I'm going to use map and lambda to do that. Okay, so let's take a quick look at how we can do that. And I'll explain it as I walk through it. So I'll define my lambda. And this time I'll just call it the lambda map flow. I won't do 2 separate functions. I'll just put it all into one. Okay, it's an empty parameter list, no parameters. All right, so here I'll create a simple list called nums. And I'll just assign 1, 2, 3, and 4. We'll keep it really simple. Okay. So that we can see what the original lists look like, we'll do a quick print. All right, so we'll print out the list. We'll say the list, comma, nums. All right, so we're going to display the list first so that we can see the differences after it has propagated through our lambda function. All right, so the first thing we want to do is to ask the user to enter a number, right? What number do we want to add to each of these values or elements inside of our list? All right, so we'll create a variable, call it number, and we'll use our input function, and we'll say add, or we'll say enter a And we'll do it this way. Add what number to each. Okay? And as an example, like 7, all right? So the user can type in any number that user wants to add. So if I type in the number 7, what my map and lambda functions will do, specifically my lambda function, right? We'll add 7 to 1, that will make it 8. Add 7 to 2, that will make it 9. 7 to 3, 10, and 7 to 4, 11. Right? So that's the goal. Instead of us creating this huge function to do that, right, we're able to use our lambda functions. All right, so we want to add this to, again, a try block. All right, just in case that user types in something else besides a number, all right, we want to catch it gracefully. All right, so we're going to first convert that number to a float, all right, because we cannot do any calculations on a string, right? And that's the way that the input function receives it, as a string, and stores it there in the number variable. So we're converting it to a float here. All right, so we're going to say to the interpreter, right, try to convert this number that was just entered into a float. All right. If it works, then we're perfectly fine. If not, then we want to catch it here by using our value error exception, right? And in this instance, we'll just simply print out not a number, period, and we're going to assign the number 1 to it, right? We're going to assign the number 1 to n. And this is just another way in which, right, it will prevent your program from crashing, right? Or we could have prompted the user again, right, to, okay, you didn't enter a number, re-enter the number again. We could have added it to a while loop, right? We could have, but this is just to show you there's other ways in which we can do this too. Adding it to a while loop will be the most efficient way, right? But for this demonstration, just to show you there are other ways that we can implement this. All right, so if the user does not type in a number, we're going to assign a number for him or her, for that user. Okay, all right, so now let's transition to our lambda function. All right, so here, let me type it in first. So let's say that the user did enter a valid number. All right, so we're going to use that. All right, so what is this actually doing for us? All right, so I like to kind of break things out. All right. So, and like math, we start inward and we work our way out, right? So we're going to start with what's inside of our inner parentheses first, and then work our way out, right? But in order for our math function to work, it needs a function. In order for map to work, it needs a function, right? So that it can apply that function to all of the items, right, in the nums list, right? So our function, so what I'm saying here is if I didn't have this right here, right, map needs a function to work on, right? So we're adding the lambda as our function, okay? And lambda is very easy, especially for you math geeks out there. It's just simply applying the f of x concept, right? F is our lambda function. X is the value, right, that will be used inside of whatever mathematical operation that we have on the right side of our colon. All right, it's doing a lot more than that, but just to keep it really simple, lambda is basically, it's an anonymous function. We call it a one-off function, right? That's passed into this map function. And in order for map to work, right, meaning map to apply this lambda function to each item, right, it needs this function, this lambda function here. So what lambda is going to do is to basically transform the x values. Okay. So basically what we're going to do, we're going to iterate through this loop, right, of nums, this list, right, this list of nums, this nums list, right, and each element inside of this list, right, is passed into our lambda function. Okay. So each element in our nums list is passed into our lambda function. Okay. So what does that mean? So that means that number one will be passed into our lambda function. So let me just put it here. Number one would be passed in there. And what is the mathematical operation? All right. The mathematical operation is to, in this instance, it would be, let's say if we entered 7, 1 plus 7. All right. The next item in the list is 2. All right. So we're passing 2 into our lambda function. All right. It will be 2 plus 7. So 7 is the number that the user entered. Right, that we converted to a float and we verify. So the 7 is where the n value is. So it will continue through the entire list of nums, or iterate through that list of numbers, right, and apply that action. Let's go back to our original formula here. Right, and it will apply x plus n, right, to each element inside of our list. All right. So it's going to add the number that the user entered to each element in the list, which will give us the sum. All right. So the result of that is then converted into this list, right? And is stored inside of this variable result. So just remember that the lambda is just an f of x function. That's all it is, right? We could come up with any type of mathematical formula. We can say divide, all right? We can say subtract here. All right, we can say multiply. We can have the Pythagorean theory here if we chose, right? Right. Whatever formula we have here, right, we're going to pass that x value from our list, which is each element, into that function, and it will apply this formula to it. Okay. So in this instance, we're just simply keeping it simple, and we're adding, right, each element in the list to the number that the user entered. Okay. But this is the key, right? Lambda is just an f of x function. You'll see that a lot in Microsoft. You'll see that a lot with Amazon's. They're called Lambda functions, right? And there are a lot of different ways that you can actually utilize these. Many, 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 many ways. This is just a simple way to explain it, hopefully. All right, so finally we have the result, right? We actually know what the result is going to be already, 8, 9, 10, and 11 if we enter 7. All right, so we want to see what the output looks like. Okay, so if I scroll down here, and let's type in, okay, we'll do a print, and we'll do original. Okay, so we're actually kind of printing out that nums list twice. That's fine. Okay, so the original list, Okay, then we'll print the added. Added to each. Arrow there. And we'll get the so here, right? So what value will go there, right? Our n value. So you notice when I highlight n, it highlights every n value or n variable. So what does that mean? And that means it contains the same value. All right. So if the user entered 7 here, all right, it will convert it into a float and then assign that 7 as 7.0 in our n value. So what this print is saying is added 7.0 to each, and here's the result. Okay. All right, so let's scroll down here, and I think it's number 5. They're kind of out of order, but that's fine. All right, so here, the choice for the Lambda map flow is option number 5. I import it into my application module. All right, let's scroll over a little. We can see it there. It's being imported. So if you notice here, we just have, it's a plethora of each function being imported. All right. There are different ways in which you can do this, but this is definitely one way. So let me exit out properly instead of crashing this thing. All right, so I pressed 0. So now let's run this line of our application, all right, and choose number 5. All right, so if I choose add to each number, lambda and map, which is number 5, it will prompt me add what number to each. And let's just do 7 just for kicks. All right, so if I type in number 7, all right, we have, okay, it shows that it converted our 7 to a float 7.0 because I only typed in 7. I didn't type in 7.0. So our conversion, all right, our cast is working the way it should. All right, so added 7.0 to each. So 7 plus 1 is 8.0. So it can, all of them are now converted, are displaying as floats because 7.0 is a float. Okay, 7 plus 2, 9.0, 7 plus 3, 10.0, and 7 plus 4, 11.0. Okay. Really, really nice. So, all right, again, so here you're just getting a really short, quick lesson on lambdas and maps. Right, and definitely expect to see there are many more features to that type of coding as well. Okay, all right, so if there are no further questions, let's take a look at how to use the pass keyword. Right, and the pass keyword is basically when you want to create a stub or a placeholder, right? And it's just showing you how to wire your program. You don't have the code for it yet. The implementation is what we call it. We don't have that yet, but we know we're going to need this particular feature or this particular function. So we can create a function. We'll call it future feature. Future feature. Say that 5 times. Right, future feature. And this time we'll just use the pass keyword. Right, again, this is just a placeholder. I know I will need this function to create a certain feature, right, for my application. Features are items that are functionality that you're adding to your application, right? If I want my application to authenticate, that's a feature. If I want my application to print, that's a feature, right? So features are just basically functions or functionalities that your application is able to to execute or to do. Okay, so here, this simple pass keyword creates what we call in programming a stub, right? It doesn't do anything. It just simply holds a position, right? Or it helps us wire our program, right? Or structure it the way that we know it needs to be structured. And then later we'll go back and fill in all of the behavior or the various tasks or the implementation for that feature. Okay. So do I have one for that? Yeah, let's see. Yeah, I do. So number 6. So I'll exit out properly again. And it says goodbye. All right, so number 6 is the feature. Okay, and it kind of gives us, this one did a print for us. We should have, well, we didn't want to do our print here because it's empty. All right, so let's import that function. Okay, so here we have our imported function, feature. All right, so when I run it, it's option number 6. It will just simply print out because I've added a print statement here. All right, normally if this print statement weren't here, it wouldn't do anything. It would just do nothing, right? But the print statement states stub call, no behavior yet, basically. Okay, so when I run this code and choose number 6, all right, it shows me that, all right, the stub was called and there's no behavior. So if I just, let's say if I comment that out, all right, and well, let's stop it if I need to recompile it. All right, and we'll choose number 6 again. If you notice, there's nothing there, all right? And it's doing what it's supposed to do because we haven't added any implementation here to this function, okay? All right, so I'll uncomment that out. Let's see if I have to recompile it in order for it to display. Yeah, just as oh no, yeah, I do. You have to recompile it again in order for it to display. Interesting. All right, so run it again, choose option number 6, and now we have, again, our output. Okay. All right, and finally, for the very last demonstration, okay, I'll create this simple Azure integration application, right, or function, right, that this is where we'll call an Azure Translator, which is part of the cognitive services, via HTTP, right, hypertext transport protocol, right? And basically what we're doing, we're sending a request, right? We're sending a request to this API, one of Microsoft's APIs, right? And which is a model, right? And this model will translate our text into any type of language that we have defined or any type of language that we chose, if, right, or that you choose to have defined in your application. Right? What this will reinforce, it will reinforce value returning functions, how to pass arguments, all right? And then, of course, separation of concerns, which is what we've been implementing here throughout this demonstration with using our flow functions and our helper functions, if you will. All right, helper functions are functions that do the work. All right, in this instance, and the flow functions are, again, manage our input and output and validation. All right, so this particular function here is an Azure Translator, right, that will translate our text into a different language, basically. Okay, so I'm gonna stop sharing. Let me pull this over here. Let's see if I can just pull it over here and hopefully you see it. And not sure. So let me stop sharing for a minute. I want to make sure that I have this correct. So if I stop sharing just for a moment, and I have you there, right? And let's share desktop number 2. Okay, great. All right, so the same as last week, right? So if I go back to my home, I've basically logged into my Microsoft Azure platform portal. All right, and as you can see, there's the text analytics demo that I did last week. So the only thing you'll have to do again is simply create a resource group for the translator, right? And then create the actual translator itself, right? And that is a part of this translator group. All right, as we can see here, the Lewis Language Translator. All right, so if I click on this translator, so this is a resource, right? This is the resource that's inside of our resource group, right? Again, what you will need in order to use Microsoft's Azure's model, you'll need an endpoint, right? So what is an endpoint? An endpoint is a location that you want to gain access to, right? The name kind of defines itself, right? So if I click on this link here, it tells me where I need to, what the URL format is in order for me to use this model, this AI model that Azure has built that will translate, right, one language into another language. All right, so here I'm going to use text translation. Right, again, I have 2 keys, and my keys are basically passwords that allow me access or permission to use this cognitive Microsoft translator, right? And in order to use this, I need to append, and you'll see in the code, translator to the end of this here, right? So it points specifically to the service or the API model that I'm wanting to use, okay? All right, so I'm gonna cancel out of that. And let me stop sharing for 1 second. Let me pull up the IDE once again. Kill that. Okay, there's the IDE, and let me go in. Let's share the screen one more time. And share desktop number 2, bingo. All right, so I'll expand that so we can get the full view there. All right. Okay, for simplicity, because I know this demo, I'm trying to shorten them as much as I can, but there's just so much to discuss. All right, so at any rate, so I'm going to create this Azure Translator function, right, that accepts 2 arguments, and it will be able to translate your text from one language to another language. Okay, so let's do that. And I believe that is our very last option there. You got it. All right, so let me pause this. So for time, I am going to copy and paste. I apologize. I like typing things out myself, but it's not super lengthy, but it's long enough to extend a little bit more time than what I want to extend. All right, so I'll copy and paste that. Okay. So the very first thing I always like to do, and I can always change these keys, ladies and gentlemen. So I'm going to copy or cut these out, and I'll put them at the very top. This is where they should be, right? However, there's also a way in which you can do this. You can also use the environmental settings, which would be the way that in the real world that we would definitely utilize. We would never have our keys open and exposed this way, right? But for simplicity, I'll just leave it as is. Okay. All right, so if you notice here, so let me go back to this very quickly. Okay, so here's my the key, right? The key that I just showed you in the Azure platform, right? This is basically my password, right? That allows me permission or access into this Azure endpoint, the translator, right? I also have to specify the region that I'm in, right? I'm on the East Coast, so I'm using the East US region, okay? And I've assigned all of these different values to constants. All right, as you can see, they're all uppercase, all right, and they specify what each represent, key, endpoint, and region. All right, so in my code here, all right, so in the code here, all right, the very first thing you'll see is that I am assigning those constant values to variables, key, endpoint, and region, right? I am defining, before I do that, let me go back and look at our definition, right? The signature and our parameters. All right, so here I'm declaring a function translate text Azure. All right, so the text will be the source of text that I want translated into a different language. All right, here I am using a default parameter. All right, and this default parameter will always have to go after, all right, any parameter that is not a default parameter. All right, so I couldn't reverse these in at Word. All right, so my default parameter is Tulang, and I'm assigning Spanish to it at this current time. All right, so what this simply default parameter states is that if the caller of this function, right, does not supply a target language to translate to, it will use Spanish. All right, I could have put English, French, Portuguese, I mean, any language here, right? But if the user does not specify or pass in a argument as a language type to translate, the default will be Spanish here. Okay, so hence our default parameter. It's kind of like somewhat like a safeguard, if you will. All right, so if we scroll down a little bit further here, what we will see is our configuration guard, right? This is what we call, or what I call, the configuration guard. So before I do that, I'm reading the credentials, all right? Read the credentials. And then on line number 67, this is what I call the configuration guard. So if any one of these values is missing, right? If it's missing or if it's empty, the program will end with this friendly message, right? Azure not configured, and that I would need to set the key, the endpoint, and the region constants. Okay, so that's what that line of code is doing for us. All right, the next line of code here is that I'm building my request URL. Okay, so remember that path, right, that we saw, right? The Microsoft Translator.com / where we're going to add this / translate to the end of that endpoint. All right, so if we go back up, our endpoint is this. So we're adding / translate, right, to the end of that path. Okay. And we're setting that, so we're taking the path, all right, we're / translate, and we're appending it to our endpoint, right? And we're assigning that to our URL variable. Okay, so we're appending the API path, right, to form the URL path. So that's the full application programming interface, right? API is just another term that means that it allows you to gain access to some endpoint, right? Or some location somewhere. All right, so this is our complete URL. All right, so the next line of code, right, we have here are the query string parameters, line 70, starting on line 73. All right, so, well, just line 73. Let me scroll that down. All right, so here we're specifying the API version, which is 3.0. And let me make sure I'm sharing everything. Yeah, which is 3.0, right? So it selects the translator API, the correct version. The toLang, right, sets the target language dynamically from toLang, right? So this is the parameter here that we're going to change, right, when we want to convert it to either Spanish, French, right? This is the argument or the value that will be passed into our function. Okay, the headers. The header section here is just that, right? It specifies our key, the region, right? We're actually converting, right? We're sending JSON type, right? JSON type is just basically where you have key value pairs, right? We'll probably talk about that a little bit further. So it's just the format, right, in which we're sending the application request or sending the request to the API. Okay. So we're sending it in JSON format, right? You could have HTML format, right? But we're sending it in JSON format. Right, the UUID, right, is where you'll generate a per call. It's this particular type of implementation is good for debugging, right, with the Azure logs. So it's screaming at me, so I need to import that UUID. So if I scroll to the top, notice I have imported it on line number 3. Okay. All right, so the next line of code, line number 82, is the request body, right? What text are we sending to have translated into a different language, right? So the translator expects an array of objects with a text field, right? So we're sending exactly only one item here. One item. So what we have here, this is a dictionary, and this is for the most part how JSON format looks, just like this. This is, but in Python, it's also called a dictionary, right? And a dictionary, it sounds exactly the way it sounds, right? And if we open up a book, it's a dictionary, right? And we have all the terms listed on one side, cat, and then the definition on the right side. Well, a dictionary, the concept is the exact same thing, right? And dictionaries are defined by curly braces, right, in Python. All right, so we have text. Well, what is the text? Whatever it is we're going to type in, right? So here we have this object, right, with a text field, right? And we're only sending one text, one type of text, right? So it's a dictionary inside of a list. So we can have a list of dictionaries inside of our list, right? But we only have just this one. All right, so that's what the body is. It will contain the text that we type in shortly. All right, and then the next lines of code, right, we'll start with the try first. Hopefully I'm explaining this where it makes some sense to you all. Even though I know we haven't covered any of this, but this is just a good way to kind of integrate how we are able to use Python functions in the real world and then play around with some of the more latest technologies, if you will, in artificial intelligence. I'm really big on that, and Python is just a perfect language to demonstrate it, right? As you're learning your Python. So here, right, this line of code, we're implementing our try. So we try to make a call, right, to our API, right, by using this request post. So it's screaming at me. So I need to import this. Come on, I need to import you. It says create parameter request. No. right, so since it's being stubborn, I'm going to force my import. Let's see what it has up here. I'm going to check to see if all right, so I just had to force it. It was trying to force me to create a parameter request, which it didn't make sense. And let me just double check to ensure. Okay. All right, so what I simply did was to import the request module. All right, so now we have the request, and a request is basically sending your information that you're typing in. It's like a packet, right, that contains parameters. So let's just kind of walk through it real quickly. So the post simply says, send this call, right, with the params, right? The params become the query string. So our parameters that we've set, all right, here, the version and the language that we want to convert to, the headers, all right, the key, the region, and our UUID, and our JSON, right? So JSON does a thing. This will serialization simply means to convert this entire request into HTML form. And then you'll see very shortly, then that's the request when we're sending it so that so that the API can understand it, right? When it's returned back as a response, it's going to take that JSON function and convert it back into Python, into a Python object. So that's what serialization does. It converts it from one form to the next form, and JSON is really good with that. All right, so this timeout here prevents it from hanging. So it just says timeout after 10 seconds, right? The raise for status, right? It throws some HTTP errors, right? For any type of 200 responses, right? So that we can handle them, right? And here, the data, this is where the response is returned. So I submit the request to the API, to the model, right? We check for any errors there, right? It will raise some error status, 200 if we get that, or non-200, any type of error, HTTP error, right? But let's say that everything was successful. If you notice here, we're getting the response back, right? So this is not a request, but the response from the model. So we'll take that and convert it back into a Python object, right? Our list, our dictionary. And that's what serializing does for us, right? It will then take and extract the data out of that data object. So first we grab the item, okay, which is translation, and then the text. All right, and just to give you an idea what it looks like, I know that it's a bit much here, but just to show you what it looks like real quick. Sometimes visualizing, seeing the actual full visual a different way makes a difference, then I'll remove it. Right, so essentially, right, so we have a list, right? So it's almost like we have a list inside of a list. All right, so we have our list, then we have a dictionary that requires that first we're extracting the translation, all right? And then inside of that, we have a list, right? And another dictionary, and we're getting the text and hola, and we want to Spanish, but it should probably be English. Okay, so this is how this line 89 is drilling down and extracting the data, the text that we typed in. Okay, no, that's beyond this maybe beyond this course. But at any rate, it's always good to know. I always like to know what's going on underneath the hood. Firm believer that understanding what's going on underneath the hood helps you really understand specifically how the code really works. So at any rate, so then we have our except, so our try except. So we use this exception to catch any HTTP errors, right? And it will return any type of status, any type of, any type of error, right? Error code or status code. And then it says to extract the first 200 characters from the body, response body. And this is often helpful. Azure has these really super helpful JSON errors that will help you, right? And then if you notice, we have two exceptions, right? Or two excepts. All right, we call them exceptions in Java, but here in Python, we call them except. Well, you know what I mean. So here we have a second exception, right? So this exception, try catch, correction. I'm sorry, not except. In Java, we use try catch and then the exception type. So here in Python, we use try except. All right, so this exception here is like a catch-all, right? It handles any other exception like network issues, JSON parsing problems, and it will display this message for us. This E is just an alias, right? And it will translate our error and it will display whatever the error message is that was triggered. Okay. And we do have a translate flow, right? So we're prompting the user that will handle our input and our output. So we're prompting the user to, in our next function, we're prompting the user to enter the text to translate. And then we're prompting the user to type in what language we want to translate to. All right, so French, Spanish. So we'll do French, I guess. All right, and then it displays the translation. So if you notice here, we're invoking translate text Azure. We're passing in the text, and then we're passing in the language. All right, so here, let's scroll up. We're passing in the text, and then the language that we want to translate it to. Okay. All right. So again, we're using functions. All right, return functions that are returning values, right? And void functions. But here we're using definitely return functions and functions with default parameters and functions with just parameters that are defined. All right, so for our last example, so if we uncomment out and let's import transport flow. Okay, so we're going to choose translate flow. So we're going to choose option number 4. All right, so let's run it again. Okay, just want to make sure I had everything there. And there are no errors. Yeah. All right, so let's run it. We'll choose option number 4. Okay, enter text to translate. And we'll say, good morning, everyone. Okay, the target language. So what language do I want it to translate good morning to? All right, we'll do French. And there it is. Bonjour à tous. It translated it to French for us. Isn't that cool? So not only are you learning functions in Python and some basic Python, you're also learning some Azure AI tools, right, that are very useful in the real world. So at any rate, good people, that concludes my demonstration for Module 4, Functions. Again, if you have any questions or comments, please feel free to send me an email, and I will most definitely respond. Everyone have a great evening. Thank you for listening.